Alright, for 5.3, we're going to talk about integrals and get the main thing about integrals is the average of f from a to b.
That way I can watch and maybe I'll learn more.
And the way we're going to express this is it's 1 over a minus b of the integral a to b of the function of f of x dx. So, kind of what's going on here is like when we were looking at the integrals, like I talked about before, the integral is kind of going in the reverse of the derivative, right? Direction of the derivative. So, in essence, when we take a look at something like if t is measured in meters per second squared, so if t is measured in meters per second squared, right? And t is measured in seconds. So and t implies seconds, right? Then when you have an integral of a to b from f of t, right? Then what's going to happen to it? And what happens is you basically take these two and you multiply them, so you have m over s squared times s over 1, and that equals m over s. And notice how we're going backwards. And so if you realize that this is really acceleration and this is really velocity, then you realize that, oh, okay, so velocity, the derivative of velocity is acceleration. When you take the derivative of velocity, you get acceleration. That's what we learned in 124. Now we're saying, oh, the integral of acceleration is velocity. So we're just going backwards. And that's kind of how we got there. Okay? So that's what they're kind of asking you to do 1 through 7. Okay? Is look at what's going on. And so the key there is right here, is doing this kind of math.
Okay.
Okay? And so they take what they tell you in the units, multiply it by the amount of units that's in t, right? So f of t would be this, and t is this. Okay?
Okay.
So I could do another one for you. It's like from 1 to 3. And of vt, right? And vt dt. So so now it's the velocity is in meters per second, right? And the time is in seconds, right? So what happens? When we take the integral of velocity, what are we left with? And we're just left with the meters, right? So the only thing that we're left with there is the distance that's going on. Okay? So so that's where that's where we're going with this. Okay? So that's not too bad, right?
That one's confusing me a little bit.
This one?
Yeah, the one you just did.
Well, we did velocity, right? So we had it in meters per second.
Seconds.
And then
Seconds.
seconds is the time,
Time.
right? So this times this is this,
Because it crosses out.
because
See,
it crosses out the s's.
See, this is your
Yeah.
equation.
And so,
and then
Then m times 1 equals m.
Yeah,
Got
yeah,
it.
m divided by
Well
1.
divided by 1.
Yeah. So, and that's really, I mean, it looks really simple,
it's just
and
numbers.
it really
Just
is
numbers.
simple. It's
So it doesn't look
It's
that
just
hard.
confusing because all the numbers.
It looks
but
really
it's
hard,
just-
yeah. I
it's
mean,
just
it looks
algebra.
hard,
It's just algebra.
but the math is easy, and you're like
Yeah.
going, it can't be as easy as that,
No, I'm
because
like,
that
there's
looks a
a-
lot harder than that. But no, it is as
So
easy
it's-
as
it's
that.
like-
You just
It's
gotta know
like
how
algebra.
to read that little interarguable sign and stuff. That's what makes it look confusing. The little
The
sign or whatever it goes.
and what
3
they're
to
doing
1.
is they're just getting you into
See?
to understanding
3 to 1,
what's
T,
happening
T.
with the integrals. So they're not, you're
Oh,
not
see,
doing.
I would have never not known that. When you do it up there like that, then it's easy. But when you look at it in here, it's like, whoa.
Yeah, you see what I mean? Now?
The 3 and the 1.
See, 3 to 1, and then where VT dt, where VT is velocity in meters and seconds. That's the meters, and the meters versus seconds or whatever. And then T is time in seconds, so T is just seconds.
So then if you look at like,
And then boom, boom.
if you look at
It's
14,
just algebra.
water is leaking out of a tank, right? Water is leaking out of a tank at
What number it is.
Yeah.
14. Water's leaking out of a tank at the rate of RT. So your rate is big RT,
RT.
okay?
Gallons and hours.
And so that's telling me that it's gallons
And hours.
in hours over hours,
Yeah.
right? Okay. So whereas T
It's measured in hours.
is hours, right?
Time, hours, and
So now I know that the integral of this, right, goes from what? So,
it goes from
What's the interval then?
our
so we have,
Water is leaking out of the tank at a rate of RT. Gallons
write
per
the definite integral that the expression of the total amount of the water that leaks out of the first 2 hours. So this is A to B, you know. So now I just want to go, okay, my integral is A to B of R T dt. Okay? So that's my integral, but when I'm talking about doing it over the first, how many hours? 2? Then I'm talking about going from 0 to 2 of K, or no, R, sorry, that's an R, T dt. So that's kind of part A. Okay?
How am I going to come back here at 2?
And then part B, it says shade the region whose area represents the total amount of the water. So now, like it shows you that little graph down below. And you had, so if you're talking about the hours from 0 to 2, right? Then you're talking about from 0 to 2, then you're shading in that region. Give an upper and lower estimate of the amount of waters leaked. Now, so now we're back to this whole thing.
Oh, we gotta find our upper and lowers again.
Yeah. So now we're just talking about our uppers, 1, 2. So now we're talking about, oh, I have 1 and I have 2. So now again, you're just talking about this upper, this is lower, right? And this is upper.
See?
Okay? And then this is lower. Right? And then this is upper. Okay? So now you have your upper area, which is the area of the black plus the purple, and the lower area, which is just the black. Does that make sense? And that takes us back to 5.1.
Okay.
Okay, so it really not too bad. Now, if I were to say, you know, what's your when you do the integral, what are you left with? So what are you left with when you multiply hours times gallons? Gallons over hours times hours.
You're left with gallons times the one.
Just gallons, right?
That crosses out.
And that's it.
Yep.
Kind of simple.
It's not that tough, actually.
No.
Not if I'm getting it.
No, it's really not. No, it really isn't tough at all. In fact, I think I gave most of this the first day. So, I mean, you can see why you can go through Chapter 5 really fast. Now, the next part, 5.6,